Lesson 12, Fractions as Division. On the screen you can see 8/5 can be written as 8 times 1/5 or as 1 3/5. Here's our word problem. 3 friends share 13 ounces of candy. How many ounces will each person get? As always, I'm going to use my cube strategy to make sure I get all the information I need. So first, I'm going to write what does cubes mean for me. Okay, first I'm going to circle the numbers. 3 friends share 13 ounces of candy. Well, here's a number. It's written in word form, but it's still a number. And they're going to share 13 ounces of candy. Next, I'm going to underline the question. How many ounces will each person get? Okay. Next, I'm going to box the math action words. 3 friends share. Share is a math action word for division. So is the word each. Next, I'm going to set up my equation. 3 friends share 13 ounces of candy. What's going to get split apart? I don't think I'm going to split up their friends. I think I'm going to split up the candy. We love to split up candy. So I'm going to put 13 is my dividend. And we're going to divide it among 3 people, the friends. So 13 divided by 3. Now I'm ready to solve. In this lesson, we're going to talk about how you can use your division equation and put it into fraction form. So 13 ounces divided by 3 people. 13 will be your numerator. The dividend and the numerator are the same number. The divisor and the denominator are also the same number. 13 divided by 3. Take a look at the fraction bar. Does it remind you of anything? It's that same bar. The fractions are actually division. So, let's divide. 13 thirds. We can do this one of 2 ways. We can use a number line, or we can use another model. In fact, you could actually divide if you really feel comfortable. Let's do the number line first. So I see that 13 thirds is on the screen. I'm going to need 3 wholes I'm going to have to show, not 3 wholes, sorry. I'm going to have to show thirds. So what I'm going to do is, I'm going to start off with 0, 1 whole, 2, 3, 4, and we'll stop there. 1 whole, 2, 3, and 4. In each whole, there will be thirds. The denominator tells us how to cut up each whole. So I'm going to cut it up into 3 pieces. So now you can see we have 1/3, 2/3, 3/3, 4/3, 5 and 6, 7/3, 8/3, and 9/3, 10, 11, 12, and 13/3. Well, 13/3, how many holes did I touch? How many whole numbers did I use? So I'm going to draw my thirds. I'm going to change colors so that you can see clearly. So here's my first set of thirds. Here's my next set. And And the next set. And there's my 4. And there's the next set of thirds. Okay. And we only got to this here. So I'm going to shade in all the thirds that we used. First, we had 13 thirds, so I'm going to shade them in. 1, 2, actually I don't like this. Let me switch to the highlighter. 1, 2, 3 thirds, 4, 5, 6 thirds, 7, 8, 9 thirds, 10, 11, 12 thirds, and finally 13. How many whole boxes do you see? How many boxes did I color in completely? 1, 2, 3, 4. So 4 complete boxes. And how many thirds were left behind? Just 1. So 1/3. Each person will receive 4 ounces and 1/3 of an ounce. Okay, let's go. Here's another model. We have 13 thirds. I'm going to draw what I have. So I'm going to do 13 circles. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And how are these going to be split apart? Your denominator will tell you that. I need to split each of these circles into 3. So that might take a while, but that's okay. I'm just going to draw a Y, and that's going to split it into thirds. So I always draw first what my numerator says, because that is what I have. That is what I'm splitting apart. And I proceed to then split it apart. Next, I'm going to color in one piece, because this is 13 thirds. So I want 1/3 out of every single one of these pieces. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now if I put them all together, I will see different holes being formed. So every time I get to 3, we're going to tally as one hole, because 3 pieces makes one hole. 1, 2, 3. So here's one group. We're dividing, so that's one group, one hole. 1, 2, 3. So here's another hole. 1, 2, 3. Here's another one. 3. 1, 2, 3. This one's a little lopsided, but it's still a good group. And there's one little piece left over. There's not enough to make another group. So in total, we had 4 holes and one little piece left over. 4 and 1/3 is our answer. Now here's a question for you. What if instead of 3 friends, it was 5 friends that showed up? How would our model look different? How would it look different if instead of 3 people, we had to share it with 5 people? Well, I would still have to draw 13 circles because that's what I have. Would I still draw division of 3? Would I still draw 3 pieces in each circle? No, I would have to draw 5 because we're going to divide it by 5 people. So keep that in mind when we're working this week, that these models will change if the denominators change or even if the numerators change. It's going to change the way we draw things. We always draw what we have, the numerator, and then split it apart, the denominator. So here's a question from our homework. Brett lives 3/10 of a mile from school. If he rides his bike to and from school each day, Monday to Friday, how many miles does he ride? Well, he lives, so I'm going to put Brett on the screen. He lives 3/10 of a mile from school. Here's his school. Yeah, there's always a flag out front. Here's his school. It's not a great school, but there it is. He goes to school on Monday, Tuesday, Wednesday, Thursday, and Friday. But he doesn't just go to school, he also comes back home. So he's going 3/10 to school and then 3/10 back. 3/10 to school and then 3/10 back again. 3/10 to school, and then it keeps going every single day. He goes to school and then he comes back home. So how many times does he do this journey? Think about it, and you'll have your answer. When you figured out how many times he goes to school and comes back home, you'll know exactly what you're doing. You can either use repeated addition or even multiplication to figure this problem out. Good luck. Here's a question from our next page. Gus is making 48 ounces of spiced cider. If he serves an equal amount to 7 people, will each person get more than 1 cup of cider or less than 1 cup of cider? Let's see. Our little friend here has given us a clue that 1 cup is the same as 8 ounces. So, he's going to make 48 ounces of cider. He's going to serve it to 7 people. I wonder if each person will get more than 8 ounces or less than 8 ounces. Here's our question. And our math action words, equal and each. This is definitely a division problem. So I wonder what your numerator will be and what your denominator will be. Which thing is getting split up? The drink or the people? Once you figure that out, you can do the math and do your division. If it's more than 8 ounces, then people are getting more than a cup. If it's less than 8 ounces, then people are getting less than a cup. Good luck. Here's our last problem. Rafiq is making a fruit punch using 48 ounces of grape juice and some seltzer water. We're not sure how much it is yet. He wants to make 10 equal servings that are at least 9 ounces each. Should he add 32 or 48 ounces of seltzer water? There are 2 problems here. we need to figure out what happens if he adds 32 or if he adds 48. So if he's making a fruit punch, he has two options. He can either add 32 ounces of water, or he can add 48 ounces of water. Find out the total, and then you'll be able to figure out your division. He wants an answer of at least 9. He wants everybody to have at least 9. So when you figured out how much seltzer water he's adding in option A and how much he's adding in option B, and you're going to split it among 10 servings, you'll figure out, hey, which one is a better option? He wants 9. So if one of these options is less than 9, he shouldn't choose it. So this is a multi-step problem. We've got addition going on, and we've got division going on. Once you've figured out how much he is making and how to divide it, you'll know your answer. This has been lesson 12, fractions as division. We talked about different models. We talked about how we decide which numbers go where, how a numerator is the same as our dividend, and the denominator is the same as our divisor. We've talked about improper fractions, one like this. We've also talked about mixed numbers. And you may have even seen a few examples of how we can use multiplication as well.